Okay, so in this video we're going to do an example problem using the min and max functions, and we're going to be finding local minima and maxima of the function y is equal to x sine of x. So the entire problem is we're told that we have the function y is equal to x sine of x, and then between the range of 0 less than equal to x less than equal to 6, we're going to find local minima and maxima, and then there's a total of 101 elements in between, and 0 to 6 inclusive. So the first thing you do is you assign or you declare x. So x is assigned linspace 0, 6, 101. So this creates a vector x that contains of size a vector x of size 1 by 101 that contains values between 0 and 6 inclusive, and that total of 101 elements. The second thing you do is you declare your function f is equal to x sine of x. So you have your function declared. And now you can jump into solving for the minimum and the maximum value. So the first thing we're going to do is we'll find the minimum value. And when doing so, the first thing I like to do is, or at least once until you get used to doing it differently, what you do is you say y is equal to f of x. What this does is it takes all these values of x, gives them to this function f, and then it gets the numbers, the actual numbers out of it. So when in math, if you remember making x and y table, this is similar to it, giving different x values to this function and getting the y values out of it and assigning it to this vector y. When you do this and run the program, you see that y has all these 101 elements that go from 0 to, and it goes up and down, but so it has all these 101 elements, and our goal is to find the lowest number in this vector and the highest number in this vector, and then we will use it to find the corresponding x value, and then that's how we will find our local minima and local maxima. So from when I did the min and max video, if you remember, the first thing you write inside here when you write the main function is fmin, or the location where the lowest number. So the first thing you write is the variable for the lowest number, so I'll call it fmin. Then you can write imin. This is the index at which the lowest number occurs, and inside the min function I'll put y. So what this means is you're sending the variable, the vector y to the function min, and then you're saying that find the lowest number in that function, or in the vector y, and then give me the corresponding index number. So this is what I will give you, the lowest value and the corresponding index number. Now we can check to see if our lowest value is right before we go on and find the corresponding x value. So I'll clear this out. So when I run this, we were told that the lowest value in the vector y is negative 4.8143, and we'll check our answer with this. We're told that the minimum, when you're finding the minimum, the y value should be negative 4.814349. So yeah, that seems right. And then now that we know that, and we know the index at which this occurs, we can find the corresponding x value. Because if the index of this is 83, then we know that the index for x at 83 contains the value that we want for our x min. So we will say x min is assigned, and we'll say x I min. So what this will do is it will send the index number to x and get the value from that index number. That's basically what you need to do, and I'll run it to check our answer. So we see that we see that the y value for local minima is negative 4.8143, and the corresponding x value is 4.92. So that's all you need to do to find the minimum. And then finding local maxima is essentially the same thing. You put f max here, comma I max, and you assign max y to it. So what this will do is it will send the function max the vector y. It will tell it to find the maximum value in the vector y, and then it will tell it to find the index of the max value. And then once you have that, you can use it to find the maximum value at which it occurs. So I'll call it x max, and I'll send it the index number. So here you see that you send the vector x the index number to get the value at that location. Now if I run this, I'm just gonna write this f max and then x max. I don't even need to write that, I'll just do that. Okay, so when you run that, you see that for x value you get, when you're finding the max for the x value, you get 2.04, and then for the y value you get 1.8195. So that's basically it. So that's how we find local minima and maxima using the min and max functions. Now there's a way to improve this, is by increasing the number of elements. So if you make this, for instance, 1000, it will be more precise and accurate. There are better methods of doing it. There are two more methods that I'm going to talk about of finding local minima and maxima, and I'll do that in the next video after that. Thank you for watching. See you next time.